Welcome to the February community call. Very excited to jump in to discuss some of the huge things that have been happening in the last couple of weeks. It's been the biggest month I've been part of in SEDA. Is there any initial thoughts, Peter, you want to touch on before we jump into some of the questions that we've got from the community?
Yeah, it's been a big push the past couple of weeks. We have started the audit with Sherlock now, so starting to see more sort of questions roll in their Discord from auditors that they call Watsons. So the audit is sort of two-piece. We have two senior auditors, so it's just like a traditional code audit. But then we also have the audit contest opened up to about 300 audit community members in the Sherlock Discord. So it's really cool to see it. There's like a ton of sort of like community-based auditors that are also going through the code, and the senior auditors have now been at the code for almost 5 days now. So that's pretty cool to see. Yeah, on the IVM side, we've been talking to more bridges, just kind of getting together our go-to-market strategy with our different launch partners with this product. So yeah, it's been a busy week, but everything good, and we're super excited to have the audit over in the next couple of weeks and implement any changes we have to, and get it live onto testnet and then eventually mainnet. So the whole team is cooking at the moment, and yeah, we're all hands on deck, very excited for the rollout.
Awesome. Yeah, it's been a very intense time, but it's been really cool to see the team pull together. Lots of late nights, lots of last minute bug fixes, and it's really cool to see the whole engineering team hold each other's backs and get everything pushed through.
Yeah, exactly. Hey, really quick, just a quick audio test. My audio better now?
No, I think it was
Or is
better
it
before.
worse?
That's
Okay.
worse.
Cool. It's better now?
So let's just jump into some of the community questions I've got here. So the first one is, what does the verification market that SEDA is entering look like from a business opportunity point of view for SEDA itself?
Yeah, for sure. Dami, at the moment, from our BD team, has also been sort of crunching the numbers. We were chatting about that earlier today. It's pretty interesting because the interop space has been growing super rapidly. A couple of years ago, interop was sort of a relatively new use case. I mean, we had some native chain bridges that were deployed to sort of get assets from one network to another, but sort of bridging as a service, covering a lot of different tokens, a lot of different chains, wasn't really something that was super common. And now, bridges, whether it be for airdrops or new, L1 or L2 launches, they become like a very important piece of infrastructure within the stack. So to contextualize this, right now, the total volume for 2024 was about 123 billion across different interop protocols. With the launch of chain abstraction, I think we're going to see this number greatly increase. Right now, at current volumes, on average per month right now, we're probably on track to hit like over 250 billion in volume by the end of this year for interop. But I think that what chain abstraction will help basically do is when you have these like hyper specialized chains, like something like Hyperliquid as an example, where you have a lot of trading happening right on this sort of L1 that's purpose built for one use case. You're going to have users that are interacting with that liquidity, interacting with trading there, but it might be routed through one balance or socket or a particle network, through their chain abstraction products, and then that's routed through interop, through bridge frameworks to actually power that experience. So so our thesis is that interop as a space is growing, the volume is growing, and so that's sort of why we see this IVM product as like a very cool intro and enter into the market. So currently, right now, just to give some numbers out there, if you look at Layer 0 as like a DVN product, on average, every message that's being sent through the Layer 0 network is paying about 42 cents to DVNs. So with the SEDA IVM, we're able to actually plug directly into that stack as just one example, and provide a better product, so a more premium product with more routing, with a larger security zone, with liveness guarantees. So we won't have any issues with downtime, like what happened with Nethermind and Stargate, where they had like 28,000 transactions stuck in flight for about 8 hours. So there's a lot of benefits, and so I think for this you can kind of map this out with layer 0. This is generating about 6 to 8 million in dollars in revenue for a couple DVN products today. And so SEDA is sort of entering these markets. The really cool thing is that we're not building just an IVM for layer 0. This IVM product can work for any interop protocol. And so on top of our IVM, sort of this shared security zone, we're able to have a bunch of different bridges be able to build and basically capitalize on this like one shared zone of security. So that's just sort of like some very basic numbers. In general, we estimate right now that the total fee market for verification products is probably around 50 to 75 million annually per year. And so I think with the IVM we're going to be able to capture a lot of that and bring it natively through the SEDA network. So that'll be very exciting with this rollout.
Awesome. That kind of dovetails nicely into the next question I've got, which is how does SEDA's IVM compare to the other DVMs on the market? What are some of the sort of key points of difference that SEDA's bringing to the table?
Yeah, for sure. So I think it's good to first differentiate. So a DVN is like a layer 0 specific product that's called like a decentralized verifier network. SEDA's IVM is a generalized framework that we've built, which plugs into the verification stack in a modular way into a bunch of different interop protocols. So it's kind of hard to give like a one size fits all because they all have different, advantages and benefits and sort of drawbacks. But, as an example, the majority of verification products today, whether they are called, an ISM with Hyperlane or they're called a DVN with, layer 0, or it's, a relayer with a cross, they're all sort of doing the same thing. They're verifying, chain state from one, network and publishing that chain state, on a, destination network. So the SEDA IVM as a whole is basically creating like one permissionless sort of route for chain state, to basically be verified. Today, if you want to deploy like a verification product, let's just use like Nethermind as an example. I'll pick on them a little bit here. They're a pretty centralized setup, right? So basically, how this product works today is they have a server. On that server is a multisig, so they have like single signing keys. And then that basically product, signs and verifies the chain state. So it does an RPC call, it reads the chain state, verifies that an action happened, and it publishes that chain state, onto the destination network, which gets ingested by the bridge contract and causes an action to happen within the bridge, protocol on that chain. So with the SEDA IVM, instead of using sort of like a multi-sig and some hotkeys to manage, the message passing, this is actually routed as a data request through the SEDA network. So with the SEDA network, we have our proof of stake chain, which is an active sort of like 100, active validator set. Then we have the overlay network, which our goal is to sort of have this be like 10 to hundreds of thousands of nodes. And then we have like a decentralized network of solvers that, can come and compete for, sort of data request order flow, publishing this SEDA chain. So we've basically taken a market that is dominated by trusted centralized infrastructure and created a decentralized option, which in most cases will likely be cheaper for the bridge to operate through and also reduce fees for users, while maintaining sort of the permissionless nature that we all are aiming for in crypto.
Is the IVM only for this? This is kind of one of the next questions that are coming up, which is the IVM only for interop providers, or is there some benefit to networks and app developers as well?
Yeah, so there's definitely a benefit for networks as well. So for the interop providers, when they want to support a new network, like let's say Kaido decides that they're going to launch their own L2, right? And they want to now have their token from Base be on their own L2, and they want to be able to have users, bridge capital, and developers be able to build products, and They want to convince, capital allocators to move money across their network. The number one step is we need a bridge, right? And these bridges come in very different shapes and sizes and sort of like security guarantees. So the easiest way to get a bridge is you say, hey, come deploy on our network. Let's make it easy and say it's an EVM L2. They deploy, their bridge contract. And then there's this sort of like piece of the infrastructure that isn't talked about a lot, which is then the relayer. And that relayer is then, passing that message from one chain to another. So although the contracts that sit on each network, could be decentralized or permissionless, the actual relay function that sits in between is not. It's a sort of, centralized third party that then, is doing, verification of messages. So if you're a network and you want to, basically spin up support, if you don't have a really big use case, like a huge airdrop coming or, a ton of builders, then most likely you're going to have to run this infrastructure stack yourself. So, the folks at IBC have been doing a little bit of research on how much it costs to run like relays for a lot of major bridges. And per year, it costs about $250K to run the infrastructure in a secure and scalable way for most bridge, protocols. So in general, it's super, super expensive. And so as a network, if you want native bridge support, you likely have to either be big enough that you can convince them, the bridge protocol to run their own relayer, or you have to run that infrastructure yourself, which is, what happens in the majority of these cases.
So we're just talking a much lower lift for a lot of these networks to get connected.
Yeah, I mean, we're talking a 30-minute prover contract deployment. We're talking spinning up a solver and getting some native token to relay data requests, and you're live, right? So you take a network that probably would take $250,000 and a bunch of work and a bunch of time, and you make this like accessible immediately, right? Whereas a lot of the designs that are there today are kind of like this opaque, like, hey, fill in this form, we kind of need this, but we don't know how to get it. How do we get this, software deployed in our chain?
And it's the true permissionless component that we really focus on, right? Is that the ability for developers to actually come in and build the thing they want to build without having all these restrictions and all the red tape that traditionally they have to jump through.
Yeah, exactly. And I think, a good way I've been explaining SEDA and this like IVM is, the SEDA network is like an application specific Oracle network. And then the interoperability verification module is like a program that's built on top. So when we deploy our prover, you have access to the entire SEDA network. And now you have all the functionality of any Oracle or data or customizability that you want to have all in like one simple, deployment. And so it could be the IVM, or it could be, in Plume's case, a RWA feed, right, that we're building, with RWA World. So it really provides like this sort of modular approach to, sort of, I think Jasper said like data parity across blockchains. Like that's sort of what SEDA is aiming for.
Yeah, it's a great way of putting it. You mentioned Domi, I see him on the call in the audience. When we've been chatting with some of the potential clients, I know our BD team has been smashing it recently as well. I'm curious to know which part of the pitch for the IVM has been most appealing to the different partners that we've been speaking with and the different clients that we've been speaking with. Is it more the security side or is it more the scalability side?
Yeah, it's a great question. Honestly, it differs a lot between, networks. When we spoke to, let's say, Allbridge as an example, when we talked to their team, they were building, sort of this approach where they have their V1 model, which uses like an internal relayer that they run to pass messages between chains. And then if available, they use Wormhole to route messages through there. So what that means is that for like a few of their chains and a few of their supported assets, they're able to route through Wormhole. But in the majority, they're routing through like their own, sort of central relay and verification stack. So, for them, having the ability to potentially use SEDA to speed up sort of deployments and support for new chains, new tokens, without having to always run the infrastructure themselves, that was sort of like a valuable piece for them. Other bridges that we've talked to, are very, conscious about security, right? So Layer Zero has been very actively talking about how they want to encourage more DVNs and more diversity among DVNs. and hopefully have several DVMs be run for their different applications and bridges. And so their approach is we want scalability, so we need something fast, which SEDA is great for. We need something that is able to support a bunch of different routes and networks, which typically is difficult to do with a traditional relay stack. And we need something that's like flexible and malleable that can support a bunch of different tokens at once. So it really depends like on what pain point they have. It could be like scaling to new chains. It could be like we support 12 different tokens right now. We want to support, 1,000,000. How do we kind of bridge that gap? And SEDA can help with that. Or it could be, like not getting sort of like enough sort of permissionless routes, right? So a lot of the routes are like centralized. So I think it really depends, but there's different kind of things that bridge providers kind of hone in depending on what challenges they're facing.
Right. Are we able to give any insight into who might be the first to use the SEDA IVM?
Yeah, I mean, like a teaser. I mean, we've been kind of pretty open about this. Like the first IVM module we're building right now is going to be like pretty open and flexible. So the goal is to launch this within the Hyperlane and Layer 0 stack as the first rollout. The sort of setup for us is relatively similar for the IVM for Hyperlane and Layer 0, like the type of sort of message-based bridge. And so, that's sort of the goal is to get live with, both Hyperlane and Layer 0, either at the exact same time or like with some type of, tiered rollout over like a couple weeks. But those are the first customers that we're building this IVM for.
Nice. This is kind of more of a statement I've got. I don't know if you can create a question out of it, but it's intent solver systems versus message bridge systems. Have you got a take on how that relates?
Yeah, it's the same thing. Like it's like saying a tire versus a car. Like tires are what the car drives on, right? And
Okay, got it.
the car can't drive without the tires, and the tires have nothing to do if they don't have a car, using them, right? An intent is just a message, right? It's an instruction. It's a sort of collection of instructions that says, I want this outcome, right? So if I have an intent that I want to bridge 100 USDC from Ethereum, to Solana, if you use a message-based bridge, you might be using a mint and burn model. So you send a message, right, that basically says, hey, this user sent 100 USDC to this contract on Ethereum. It's locked up. A relayer then picks that up, like the SEDA IVM, and relays that to, the destination chain and says, hey, this token was locked up. You can mint this quantity of tokens, to this address on this chain, right? So that's like how a message-based bridge works, right? But an intent, like it's kind of like this this abstraction point, right, where people kind of make it seem like it's super difficult. But when you have an intent, like that intent has to be filled some way, right? So some intent-based networks are building their own sort of liquidity and swapping network or like interop with solvers. But a lot are just like defaulting to like Hyperlane or Layer 0, right? So if you issue an intent like I want 100 USDC, that might actually, be filled by a solver who has inventory on like, chain A and they're willing to solve for chain B. But in the background, they're going to be rebalancing their funds with Layer 0 or Hyperlane or across. So in the end, they're kind of like one sort of augment of the same system. But in the end, like with intents, let's say I have $100 million on Ethereum, and over the course of a month, that's slowly drained and filled as Ethereum on Arbitrum. At some point, I have to bridge back ETH to rebalance my pools, right, as a solver. So I then have to figure out like, okay, well, how am I going to get my money back, right, to this other network? And you guessed it, message-based bridges. So they're kind of one and the same. I think they're the same thing. They're reliant on each other, and I think most of the intellectual debate going on Twitter is more for yaps and followers rather than like people really trying to make a distinction between the two.
Right, got it.
I'm gonna just add on that, Ben, as well. Like I think the other thing is like the debate is more like a UX debate and like who's going to use what, and is message-based bridging or intent-based bridging, are they in competition with each other? Where for us, as Peter said, like it's the same thing, right? Like solvers need to verify in order to get repaid and rebalanced going through the message bridge. But I think like the distinction maybe that can help people separate the utility of like intent-based bridges versus message-based bridges is when you have like an intent in like an abstraction layer, that removes the need for the user to manually interact with that bridge, right? And then the solver interacts with that bridge during its rebalancing phase, as Peter said. So the user can create their intent wherever they want through the abstraction layer, and the solver fills it. But then the solver uses that bridge. And then the other thing is that solvers only hold so much capital. So the more that volume increases through interop, like solvers are going to have more capital if they have their capital waiting to be rebalanced on different chains, right? Because if it's stuck and they're waiting to be rebalanced, I think the estimate at the moment is anywhere between 3 and 8 million being waiting to be rebalanced back to solvers on a cross, and that's just on intent-based bridge. So that's where like message-based bridges are still going to probably reign supreme, like CCIP and Layer 0 and Hyperlane is for like these larger transfers that people want to do when they're high volume, low frequency transfers, where intents will be used for users on low value, high frequency transfers. I mean, that's what the data's showing. But for us at SEDA, it's all the same thing, right? Where we still have to verify the solver on the message-based bridge or the user's action on the message-based bridge.
Very good. We had a nice bit of press come out over the last 7 to 10 days as well, Matt. I don't know if you want to give a bit of a wrap up of some of the write-ups that we got and some of the exposure that the IVM and SEDA as a whole got.
Yeah, definitely. No, I think the announcement was really successful, and sort of the metrics that we were looking at were how did it land in the projects that we want to see that piece, and obviously want to get their attention to come and use the IVM, or who will find some benefit from the IVM. And the feedback that we got through a lot of the the groups that we have with these teams was made like absolutely positive. And a lot of people engaging with that tweet from these projects as well, amplifying that the tweet of the announcement. And then it was really good to see like the PR get picked up by the Defiant, and other PR agencies. It also starts with D. It always slips my name. But then we had Binance Square pick it up, Hackanoon. I mean, there was quite a list of publications, somewhere over 100 publications picked it up. So very, very good to see it go throughout all the different media across crypto Twitter, and then to see people from different projects happily amplifying the announcement that we put out as well. So I think like all in all, it's been nothing but positivity, a lot of inbound messages from it as well, a lot more attention. And I think people are starting to see the wider story here is like this, the verification market within interop is absolutely, growing at record rates, and people are starting to put a lot of attention on it. There's been some pretty spicy blogs. There was one that came out yesterday that was by an author who's sort of raised this point before around like verification systems and why aren't we talking about kind of security and scale more? Why isn't it more of a transparent conversation? Which is really good to see for the industry, because I think it's a conversation that people need to have now, and it's really good. It's just a really good timing signal for us at SEDA that we've released this framework, and then over the next couple of months that'll start being used, and then we'll be able to see it in action. And I think it'll start to snowball from there. So no, all positive on our end from the launch. It was very well executed by the team.
It does feel like there's more and more evidence each week that the direction that we're taking with SEDA is solid product market fit. It is really exciting to see the interactions going up, the DMs going up. I know you've mentioned that a lot of other teams are reaching out to you, Matt, and Peter, I'm sure you're getting the same in your DMs. It's really nice to know that the industry is also recognizing this verification opportunity and how SEDA fits and fills that hole at the moment. I've got a question on inflation proposal, unless you want to tag on anything quickly at the end there.
Yeah, I mean, no, absolutely. I think like just very quickly, for people who've been following on for a long time, obviously last year we were sort of talking about all the possibilities that could happen on SEDA, and sort of as we kept building and talking to different developers, it just became very clear that SEDA is just so almost like, you could almost say like purpose built, not that it was, but it has such a aligned function with verification. It just fits that kind of gap in the market now from legacy models that we're using kind of these multi-sigs and outdated systems. And then you look at like the, how DVN started to roll out a marketplace, and Hyperlane with their ISMs as well, in an effort to sort of create a more decentralized approach, but they were still using multi-sig. So you can sort of see this like evolution coming, and then you put something like SEDA, which does the same verification but through a completely different architecture of distributed network, completely decentralized by default, and it almost just feels like it's a natural evolution in the verification market that some of these big players were alluding to, but didn't have the capacity to build themselves. So they were opening up to new projects. And I wouldn't say that any other project that I've come across yet could claim that they have like a hyper specialized product to fit that market. And I would say that SEDA just slots in there very, very nicely. And again, like all the inbound messages we've been getting and interest from different interop players just speaks volume for that.
Very nice. So, inflation proposal coming up. When the voting closes, assuming we get a yes, Peter, how long until the inflation is switched on? What does that sort of time frame look like?
Yeah, for sure. So the inflation proposal will be posted on mainnet. So it happened on testnet already. The vote went through, upgrade to the parameters happened. So everything went as expected, which is great. And then the mainnet proposal will be posted tomorrow, most likely sometime CET morning. We don't have a specific time, I think, that we're saying, but sometime in the mid-morning. And then from this time, it takes 5 days. So let's assume we have a yes from validators that this proposal should go through. Then we will have a 5-day period, which is a default from when this vote takes place, or when the proposal goes live, to when the software is either upgraded or not, to include this parameter.
Perfect. That's my last minute question. Is there any other general wrap up, any information about the general rollout, what we're looking at for the rest of this quarter that you want to touch on, Peter, before we wrap up the call?
Yeah, for sure. So I mean, we have like this huge upgrade, right, that we've been working on for the past 8 months or 9 months to the SEDA network. This is what's being audited now. So this is the overlay network. This is a solver network. These are the data proxies. This is Oracle programs. This is prover contracts. This has been like a huge lift from the team, right, to kind of build out all this functionality. It's sort of the first ever display of an Oracle network with so much programmability built in. So it's really exciting to see this, go into its audit now. And then on the other side, our engineering team is now slowly starting to switch focus from, network tooling to now building, the applications and programs that we want to see be the flagship on top. So right now, the first priority is the IVM. Obviously, we're building this as a flagship. So next week, we're going to be diving a bit more, deep into the design. We already built a very early prototype of the IVM a couple months ago for testing. We're going to be rewriting this to optimize the code a bit, be a bit more powerful, for these networks. And so the goal is that we will basically slowly roll out, features of the network over the next, I would say like 4 to 6 weeks, as we build the IVM in parallel and get that sort of ready for launch. So I think the end state that we're kind of aiming for is have a network live, and have basically the IVM go live like at the same time or very close to that, and then have first integrations already start testing on testnet pretty soon, so that we can start to have some production use cases very quickly on our mainnet.
Excellent. Exciting times. All right, let's wrap it. Before the end of the month, we'll have the Tech Blitz with Jasper. We'll explore a little bit further some of the nitty-gritties that the team, the engineering team, has been getting into, what's been happening while the code has been frozen, and maybe some other little interesting tidbits. So stay tuned for that before the end of the month. And if there's any other last comments from you, Matt or Peter, let's wrap it up. And thanks everyone for coming.
Yeah, thanks so much, everyone. Thank you for the questions and the interest in the IVM. And we're super excited. You can follow along in Sherlock in their Discord if you're interested in the audit, to learn how the process is going there. It's quite cool because you can see sort of discussions around potential bugs and stuff like that in real time. Yeah, I've definitely been posting a lot of stuff on Twitter recently about, sort of the IVM and its entrance into layer 0 and Hyperlane coming up. So definitely follow, along if you're interested to hear more about kind of this initial rollout and how this is going to go. And yeah, thanks so much everyone for the time.
Yeah, likewise. Thank you. And I won't go on because Ben, it's probably nearing 1 o'clock where you are, so I'll let you get to sleep. But thanks for turning up, and thanks everyone for coming.
Thank you very much. Goodbye.
Thanks everyone. Bye.